Hello and good evening, CSI158, Section 841 and 847 students for the second 8-week term during the spring 2014 semester at Anne Arundel Community College. This is the Cisco Routing and Switching Essentials course, and today's PacketTracer tutorial will be on PacketTracer Activity 8.4.1.2, and this is the Skills Integration Challenge, where we're going to pull together everything we've done with Ospf V2 and V3 and display our skills here in this PacketTracer activity. So as you look over here to the right, the addressing table is as we typically see it right here. And so we've got some background information. So the activity is graded using a combination of assessment items and connectivity tests. The instructions window will not show you your score, so we'll have to go into check results to get that information. So let's jump right in here because we've got a number of tasks we need to accomplish. The first is we use the following requirements to configure Router A addressing and Ospf V2 routing. So the Ipv4 addressing scheme will be according to the addressing table. And so as you can see here, they've actually made it a little more difficult for us. They're going to give us a /23 subnet up here for gig 00, but we're going to be just fine. So let's go ahead and hop into Router A and get to work here. So I'm going to go from user exec mode into privilege exec and then into global config. And very similar to PacketTracer 8.2.2.7, which we've previously done, the process ID for Ospf is going to be 1. The router ID will be 1.1.1.1. We're going to put a network address for each interface on the LAN. And then, of course, the LAN interface, which is facing our switch and hosts, is going to be given the passive interface command so that Ospf is not sending updates or hello packets out that interface. Alright, so let's go ahead and apply our addresses to the interfaces gig 00 and serial 010. And so first we'll go ahead and we'll go into interface gigabit Ethernet 00, and we'll go ahead and bring that interface up, make sure it's up. We'll put our IP address on here, and you should be very familiar with this activity. And 255.254.0 is our subnet. And we'll even put a description on here, and we'll just simply say LAN interface. Okay, so we've brought the interface up, we've issued the no shut command, and so that interface is up and operational. So now let's jump into interface serial 0/1/0. And I'm going to go ahead and we're going to add in the no shut command to bring that interface up. And let's get the IP address on there, and the IP here is going to be 172.31.4.1, and this is a /30. It's a point-to-point address. And we'll put a quick description on here, and we'll just say WAN interface. We'll treat it as if it's going out to the WAN for us on this router. All right, so we're going to exit one level up from the interface config mode back to global config mode. And it's here in global config mode that we're now going to go ahead and we've completed the Ipv4 addressing according to the addressing table for gig 00 and serial 010. And now what we want to do is we want to take care of process ID 1. So we're going to set up our Ospf. And again, the process ID is what follows at the end of this statement, router Ospf 1. And so it's not the area, that's the process ID. So we want to set our router ID to 1.1.1.1, and we're going to put a network statement in here for each address. So the first network that we were dealing with was 172.31.0.0, and we're going to put our wildcard mask in here. It's going to be 0.0.1.255. And so again, a real quick review is this is different than a typical /24 when we're figuring our wildcard mask out. So we still, whoops, that's a 5 there, 255, trying to get a better grip on this pen. 255.255.255.255. And so we would subtract our subnet mask, which in our case is 255.255.255. .254, I apologize, .0. And so our wildcard mask will be 0.0.1.255, right? So that will be our, I apologize, wildcard mask. That will be our wildcard mask for a /23 CIDR notation or subnet mask. So again, wildcard mask. I apologize. So used to saying subnet mask. So that's the wildcard mask. Okay. So that is going to be the wildcard mask, and that is going to be in area 0, right? So we'll enter in the area 0 command there. And then again, passive interface is going to be gigabit Ethernet 0/0, which faces our LAN. So let's do a do show run. Okay, there's our gig 00, and the serial 010 is configured. And there is our OSPF configuration, right? So we've got our first network statement in there. So now let's get our next network statement in there, which is going to be for that, whoops, I apologize, 172, and this is for the WAN interface, .31.4.0, and we know that a /30 subnet mask will result in a wildcard mask that is 0.0.0.3. All right. And that is also going to be in area 0. Okay, so that should complete our configuration on router A. So let's close down router A. Now, we're going to come up here to router B, and as you can see, router B, we've got some dual stack activity here where we're doing IPv4 and IPv6. And so let's scoot up a little bit. And so let's pull up router B and go from user exec into privilege exec into global config. And so let's take a look here with router B. So for the following requirements, so IPv4 and IPv6 addressing according to the addressing table, set the gig 00 link local to FE80::1. So we have Ospf V2 routing requirements, and then we have some Ospf V3 routing requirements. And remembering that Ospf V3, we're going to be configuring that at the interface level, and that's where we're going to be using that IPv6 Ospf process ID area 0 command. In our case, it'll be area 0. All right, so let's go ahead and walk through each of these sort of one step at a time. So let's go back up to the addressing table for router B. And we're also going to jump into gigabit Ethernet 00. We're going to do a no shut, no shut to bring the interface up. And gig 00 has an IPv4 address, and it also has an IPv6 address. So we'll put the IPv4 address on here. So IP address 172.31.2.1, and this is also /23 250. Oh, I apologize. 254.0 is the subnet mask. And let me double check over here. Yeah, okay, I did get that right. I'm going to go back and check router A really quick to make sure that I've got the yeah, .1.254, so that's correct. And let me make sure I didn't fat finger it. All right, we're good there. All right, just double checking. So here we are back on router B. So there is our IP address for IPv4, and now let's put our IPv6 address on here. And the IPv6 address is 2001:DB8:1:1/64. And we're also going to put our link local address on here, IPv6 address, and the link local is FE80:. Let me scroll down here, we just missed out on that, FE80::1. Make sure we get that right. And that is our link local address. So we've got our IPv6 and IPv4 information for the gig 00 link. And now let's go ahead. We're going to have to jump into the internet, or I'm sorry, the interface serial 0/0/0, which is going to be, we'll do a no shut to bring the interface up. And we're going to go ahead and put on here IP address, and we're looking at 172.31.4.2, and this is going to be a /30. All right, and there is no IPv6 address on that interface. And then we're going to go ahead and transition into interface serial 00, whoops, interface serial 001. So we'll do a no shut there. And we'll put the IP address, and this is an IPv6 address, so IPv6 address 2001:DB8 : let's make sure we get this right, 2::1/64, and it's not asking for a link local, so a link local will be automatically generated for us, and so we're not putting a link local on serial 001, and I'm just double checking right now, so we've got that correct. Okay, all right, so let's scroll down here on router B. So we've got the addresses set on the interfaces, so the Ospf V3 routing requirements. So let's go back to global config from interface config, and we're going to do the router Ospf, and the process ID will be 1. Again, process ID is locally significant. Our router ID is 2.2.2.2. And now we're going to set a network for each IPv4 address. And so we're going to go ahead and go with network, and this is going to be 172.31.4.0. Or I apologize, we're doing the 172.31.2. Let's do that gig 00 interface first. 172.31.2.0. And it is a 0.0.1.255, and this is going to be an area 0, and so that's going to take care of the gig 00 interface. And now we want to get a network statement on here for the serial 000 interface, which is the one I accidentally almost did first. So this is going to be 172.31.4.0 is going to be the network ID, and this is a /30, so we know that that is a 0.0.0.3, and we want this to be in area 0. All right, so that takes care of the Ospf V2 routing requirements, with the last one being that passive interface command on gigabit Ethernet 0/0. And again, that's going to be this interface here that goes out to our local LAN, so the 172.31.2. Okay, and so the passive interface has been set. All right, so now we've got some Ospf V3 routing requirements that we need to handle. And so the first one is for Ospf V3 or IPv6. We're going to go ahead and exit back out. We're going to get to global config mode, and this is where we're going to type in IPv6 router Ospf 10. And so we're going to use, I apologize, the process ID will be 1, router Ospf 1. And so we're going to go ahead and hit enter. So IPv6 routing is not enabled. So let's enable that. IPv6 unicast routing, and now let's try that command. All right, fantastic. So now what we need to do is we've enabled IPv6 routing, we've used process ID 1, and now let's set our router ID to 2.2.2.2, and we'll hit enter. And so now we need to enable Ospf V3 on each interface where we have an Ospf V3 or an IPv6 address. So let me scroll a little bit back up here, router B. Okay, so this is going to be, we're going to exit out of here, back to global config, and I'm going to go into interface, gigabit Ethernet, and we'll go to 0/0, where we do have an IPv6 address assigned to that interface. And so we're going to type in IPv6 Ospf 10, area 0, right? And so I'm telling the IPv6 and the Ospf process that this interface is going to be participating in area 10, right? And so that was for the gigabit Ethernet 0/0 interface. And then finally, we're going to go to interface serial 0/0/1, and we're going to run that same command, IPv6 Ospf 10 area 0. All right. And so we've taken care of our Ospf V3 requirements. So now's a pretty good point to take a quick checkpoint here. So we'll type in end. I'm going to do a write mem and save my config. We'll close this down. Let's see how we're doing. Let's check router A and router B results to see what we see. So router A, we're looking good. We've got all checks. Router B, we're looking great. We've got all checks. And so now we're going to take care of router C here, and then we're going to come back to PCA, PCB, and PCC. All right, so let's take care of router C here. Let's finish this up with the routers. All right, I'm on router C. We'll go from user exec to privilege exec into global config. And there are only IPv6 addresses. So let's make sure we get that IPv6 unicast routing turned on. And I'm going to go ahead and go into interface gigabit Ethernet 0/0. And we're going to assign IPv6 address of 2001:DB8:2:1/64. And let me check to see, I think we need to have some link local addresses here. So the gig 00 link local should be IPv6 address FE80::3, and that is a link local address. And so we're good there for gig 00. And the IPv6 addressing according to the scheme. Okay, so let's cruise back up here and we'll finish this up. So we'll do a no shut. I'm going to make sure that interface is up. All right. So that interface gig 00 is up. Now I'm going to go into interface serial 0/0/0. We're going to do a no shut there. Bring that interface up. And we'll do IPv6 address 2001:DB8:2:2/64. As you can see, the serial interface is now up. Right, so we've just assigned an IPv6 address to that interface. And so from the interface configuration piece, we're satisfied. And so let's take a look here, make sure we've got everything. So IPv6 addressing according to the table, we did that. We took care of that link local address of FE80::3. All right, we've enabled IPv6 routing here. If I were to do a do show run, you would see that toward the top, and there it is right there. And so that's going to tell us that IPv6 routing is enabled on this router. All right, so we're going to do some OSPF work here. We've got a process ID of 1, router ID, and then we need to enable OSPF V3 on each interface. So again, from global config mode, we're going to type in IPv6 router OSPF, and our process ID will be 1. All right, and it says not router ID, process 1 could not pick a router ID, please configure. Okay, so it wants us to configure the router ID, so we need to make sure we get that in there, right? Because it told us we have no router ID, so it needs to be configured. So we've got that router ID configured in there now, and so we're in the OSPF global piece, and so we've got our router ID in there, and so we're good with that. We've got process ID 1, and so I'm going to go ahead and type end. Right, and if I do a show run at this point, and we go down to the OSPF configuration, you'll see here the IPv6. Right, even though we saw the error, it was basically telling us, hey, you need to make sure that you get your router ID entered in here. And so we've done that. All right, so now let's enable it on each interface. So we'll go back to global config, go to gigabit Ethernet 0/0, where we're going to enter in IPv6 OSPF 10 area, OSPF 1 area 0, and then we're going to do the same thing for interface serial 0/0/0. Let me confirm it's 0/0/0. It is, right? And so we're going to go ahead and say IPv6 OSPF, the process ID, and then the area number to which that interface belongs. And it says no IPv6 enabled on this interface. Let's take a quick look. So gig 00 is good, and serial 0/0/0 was never configured on router C. All right, so I could have swore that we put that interface on there, but let's go ahead and do that again. So let's go back into interface serial 0/0/0. We'll do a no shut, and then we're going to say IPv6 address, and that address is 2001:DB8:2:2/64, and it's over. Ah, I see. So it looks like we've got a mistake. The IPv6 address that I assigned here to gig00 is, I was looking down, or I actually missed it. It's 3:::1. All right, so here's what we're going to do. Time for a little troubleshooting. So let's jump over to gigabit 00. We're going to say no IPv6 address, and then I'm going to pull it back up, and we're going to change that to what it should be, which is a 3. All right, so now this should take care of that. So do show run now. Okay, we've got our right address in there. So 2001 db8 3:::1. Is that sync up there? db8 3:::1/64. So we're good. We know our link local address is good. All right, so now let's jump back into the serial 000 interface. Make sure we've got the no shut there, and then IPv6 address 2001:db8 : and make sure I get the right address here, 2::2/64. All right, so now IPv6 is configured on serial 000. So at this point, we can now go ahead and add our IPv6 Ospf process ID of 1 area 0 command, and now we don't receive that error message. All right, so let's scroll down a little bit here. So we've enabled Ospf on each of the interfaces, right? There is no serial link connecting these two interfaces together. And as you can see there, the adjacency has been established. So I'm going to go ahead and type in and write mem, and you'll notice we've got some redness here between router B and router A. And so let's do a quick show run here and make sure the serial interface is configured and that they're not shut down. And I'm thinking that maybe one of these interfaces, the serial interfaces, may be down. 010. Let's check and make sure we've got the right interfaces. So it's, aha, so it's serial 000 and not serial 010. So let's take a look back up here and see what we missed. So it says here serial 010. However, that WAN interface is not serial 010. It's serial 000, which is why our link is red here. And this one as well is 000, but that's correct. So this is actually a mistake, it appears. And let's go ahead and troubleshoot that. Let's take the configuration off of 010 first. So let me do a global config mode change, and we're going to go into interface configuration mode. We want to take a look at serial 010. And I'm basically going to say no, and we're going to say no IP address, and we're going to need this line here in a second. So I'm going to copy it and paste it. I'm going to shut that interface down, and then we're going to get into the right interface, which is serial 000, and we'll say no shut, and then we're going to add in that IP address command. All right, so it looks like success. So again, it looks like there's a slight typo where the interface here should not be serial 010, it should be serial 000. And now we've got green links between the two. Okay, so we look good there. We've addressed that issue. Everything's looking good. We've saved our configuration off. Let's scroll down and see what else we've got. In fact, this is a great chance here, a great time. So configure the PCs with the appropriate addressing. So let's check results, and let's see what we've got so far before we jump into configuring the PCs. So as you can see, the PCs, we've got all red marks. We haven't done any configuration there. So we want to see the routers. And everything looks fantastic. All right, so the routers are complete. Now let's go address the PCs. So it says PCA and PCB IPv4 addressing must use the last assignable address in their respective IPv4 subnets. And so let me come over here. Let's flip the page, get a fresh page here. All right, so for PCA, our subnet is going to be 172.31.0.0/23. So make sure I get a look at that. 172.31. So 172.31.0.0/23. And so what this means is we've got 510 usable host IPs, and it's basically 2/24 subnets that we're going to look at from here. And so it'd be 172.31.0.0 and then 172.31.1.0. So the last usable IP that we're going to have in this range is going to be 172.31.1.254. And so this is our network ID, right? Our first usable is 0.1, which if you look over here, we're using that as our default gateway address. And then our last assignable is this, and so our broadcast address would be 172.31.1.255. All right, and so that is PCA. And then PCB, if we take a look at PCB up here, it's 172.31.2, and you'll notice that that's why this starts at .2, right, is because we've used .0 and then .1. And so PCB is 172.31.2.0/23. And so then this is our network ID, right? Our first usable would be 172.31.2.1, which, no coincidence, we're using that as the default gateway address here on the gig00 interface. Our last assignable IP would be 172.31.3.254, right? And our broadcast address would be 172.31.3.255, right? All right, and so let's come back over to our setup and let's check it out. So addressing must use the last assignable IP address. Let's do PCA first. This will be the easy one, right? So we're going to do a static. It's going to be 172. Covered up my information. .31.1.254. Our subnet mask is 255.255.254.0. And our default gateway is 172.31.0.1. All right, so I'm going to close this, and so let's do a quick check here. Can I ping my default gateway? 172.31.0.1. All right, we've got connectivity out to our default gateway. Maybe I can get to the router B interface. So let's ping 172.31.4.2. Right, I'm good there. Can I get to 4.1? All right, fantastic, I can get there. So it looks like my IP address configuration here on PCA is solid. Let's go ahead and jump onto PCB. And there's going to be some IPv6 considerations here. So we'll come over here. So the Ipv4 address is going to be 172.31.3.254. My subnet mask is, 255.255.254.0, and my default gateway is going to be 172.31.2.1. Let me double check that real quick here. 172.31.2.1. So that's correct. All right, no DNS server involved. Now, PCB and PCC have IPv6 addressing, and it must use the link local FE80 address as the default gateway, right? And then let's see what else it says here. It says finish the addressing table documentation. All right. So PCB and PCC must use the link local for the default gateway, and so that would be our IPv6 gateway, where we would have FE80 : on PCB. Let's make sure we've got this right here. I'm looking back, router B. Okay, so here's router B and the link local FE80 : 1, right? And so we're good there. And it looks like there's going to be some more IPv6 information, and we'll check on that in a second. So can I ping over to PCA? sys.31.0.1. Can I ping over to that interface? I can. Can I ping PCA, which would be 1.254, right? So I can ping over there, so that's working. And let's go ahead, and I'm going to do a quick peek here at check results, because I still think that there is some, yes. So here is where you would see the address that you need to use for your IPv6 setup on PCB. And again, that address is going to be db8:1::2, right? And so it wants the IPv6 address and the prefix, which is going to be a /64. So let's close this out, because you'll notice they don't provide you with that information here. So let's jump back onto PCB, and the IPv6 address will be 2001:db8:. Now for I think it's 1::2/64, and I'm going to go ahead and leave that the way it is, and we'll come back and check that in just a second. I need to take a quick peek back here to make sure I got the right address down. So yeah, we did get the right address and we got the right prefix, so we're good there. All right, I was trying to memorize the address by just looking at it one time. So PCC, again, same thing. Probably should have written this down when I jumped in here. So, and this is going to be db8:3::, and then 2, right? Okay, so we're going to pull PCC up, and we're going to get PCC configured. And PCC is unique in that there is no IPv4 address assigned to it. So we're going to do 2001:/3::2, and that's a /64, and the link, or the IPv6 gateway, is FE80::3, and let's confirm that. Yep, the link local address FE80::3. All right, so that looks correct. Let me close this down, and we do see that we've got OSPF is converged, and so we're going to take a look at that. In a second. So the OSPF neighbors should be established, and routing table should be complete. So let's take a look at the routing table on router A. If I do a show IP route, and you can see I'm only learning one IPv4 address, because router 1, so router A, apologize there. So router A is only learning from OSPF a single subnet, which is the only other subnet that's out over here that's being advertised, right? The 172.31.2.0. And the reason that the 172.31.4.0 doesn't show up as being learned from OSPF is because that's actually directly connected, right? And so it's going to prefer that directly connected route for the 172.31.4 right here, because it's directly connected. And so we're not learning that through OSPF, even though we've created a network statement under the OSPF process. So router 1, or router A, looks good. I keep saying router 1. Router A looks good, so we'll save our config there. Let's take a look and see what router B sees, right? And so we've have some OSPF adjacencies have been established here. Save the config right out of the gate. We'll do a show IP route. And as you can see, and again, the show IP route is, we know over here we never enabled IPv6, so even if I did a show IPv6 route, there's no information there because we didn't enable, I don't believe, yeah, IPv6 unicast routing is not enabled on router A. So on router B it is enabled. And so here you can see we're learning one IPv4 subnet, and this is the subnet over behind router A. And let's confirm that show IPv6 route, that we are learning some other routes. And so here is the route over behind router 3, right? And that's the 2001:db8:3::/64. And so IPv6 is running, and we are seeing our neighbors. All right, so let's do a quick write mem just to make sure, and we'll close this out. We'll bring up router C. And router C, if I do a show IP route, doesn't show anything because it's only IPv6. So show IPv6 route, and you can see I'm picking up the IPv6 route that sits over behind router B, as in boy. All right, so our routing tables look really good. Let's go ahead, let's check our results before we run some ping tests here. All right, we've got a lot of green check marks, so everything is complete for this assignment. All right, so we're at 100%, but one last thing here. Pings between PCA and PCB should be successful. So I'm going to ping PCA. I think we already did that. Yep, 172.31.1.254. So that's working. And now pings between PCB and PCC should be successful. And the PCC IP address is escaping me at the moment, and there it is. So 2001:DB8:3::2. All right, we can ping over there with no problems at all. And let me go ahead and try to ping from here. See if I can ping PCA. Would that work? 172.31.1.254. And you'll notice that that doesn't work because we're not routing that IPv4 information on router C, so he's not learning about the IPv4 network over here on router A. Because remember, this is only IPv6. This is a dual stack setup here, so this guy understands router B will understand IPv4 and IPv6, as will PCB. But over at router A, it's only IPv4, and so this is where if you want to do IPv6 throughout this environment, if this was your environment, you'd want to make sure you have IPv6 routing enabled on router A, and so you're doing dual stack here, you're doing dual stack on router B, and it doesn't hurt to do dual stack on router C as well. And everything would be configured similar to what's going on here on router B, where you've got both your IPv4 and your IPv6. But let's double check. Can I ping PCB 2001:DB8:1::2? And I can. All right. So again, this was the Skills Integration Challenge for Chapter 8, which was on OSPF, single area OSPF. This was PacketTracer Activity 8.4.1.2. And again, hopefully this video tutorial has helped you understand a little bit more about OSPF V2 and V3 and how to configure it in a single area setup. All right, best of luck in your studies, and see you all this week.